Greetings and welcome to the introduction to astronomy. In this lecture, we are going to talk about phases of the moon and tides, which are caused by the moon and sun. So let's go ahead and get started. So let's go ahead and start with the phases and what causes the phases to occur. Well, the moon is a solid object which is illuminated and shines by sunlight. So like any solid object, half of it will always be illuminated. So half of the moon is always illuminated by the sun. However, also half of the moon is visible from Earth. So if we look here, half of the moon is facing Earth, half is facing away. We can see this portion. So we can see the portion facing toward Earth. So depending on the combination of those two, we will see more or less of the moon illuminated as we look at it. So sometimes in the crescent section, we'll be seeing less than half of the side illuminated. And in the gibbous section over here, we'll be seeing more. So because we can see half the moon illuminated and half the moon is visible from Earth, we will see different phases as the moon moves around Earth. We have what we call the waxing phases, which are on the upper section here. In that part, the moon will be getting more and more illuminated each day. On the bottom, we see the waning phases where less and less of them would be visible each day. Now, let's also look at the timing for this. The cycle of phases is 29.5 days. Now we mentioned that previously when we talked about our month. Where does our month come from being approximately 30 days? Well, it is because the moon's cycle of phases is very close to 30 days. However, the actual revolution period of the moon is a little bit less than that. The sidereal month relative to the stars is 27.3 days. Now, why is there a difference? Well, the moon is moving around Earth and moon, or moving around the sun over the course of that month. So over 1 month, the Earth and moon system moves about 1/12 of the way around. So it takes a couple extra days for everything to line up again relative to the sun. We saw a similar thing with the day, where we had that the solar day was 4 minutes longer than the sidereal day. Now the phases that we see, the names of them, we will have the new phase when the moon is not visible. We see nothing because the illuminated portion is pointing away from us. Then we will see a crescent phase, up to a quarter phase where half of the visible surface is illuminated. Gibbous phase is more than half. Full phase is fully illuminated. And then we begin through the other section of phases, the waning, where we'll see gibbous, quarter, crescent, and back to new again. And the cycle starts all over. So the cycle will then repeat itself. Now, why these phases? Let's take a look at this a little bit closer, and let's look at this phases over the course of a month here. Now you watch the animation and we will see that the moon starts illumination on the right hand side, goes to full, and then de-illuminates toward the left hand side. So during the first half of the phases, the right side is illuminated. During the second half, the left side is illuminated. And here we're watching the moon from 2005 over one complete cycle of phases. So how will we know which phase is visible at any given time? Well, it depends on the position of the sun and moon. And when we see the new moon, they are in the same direction. So here is Earth. If we look toward the sun, the new moon will be in that same direction. And we are seeing the side that is unilluminated by the sun. So the moon would be completely dark. So we would not be able to see that at all. In the crescent phase, it will always be close to the sun. So here we're looking out this direction or this direction for crescent phase. And we would be seeing only that portion that faces Earth. So only a tiny portion is illuminated. And those will always be close to the sun in the sky. So you will see the crescent phase shortly after sunset or shortly before sunrise. By the time you get to the quarter phase, you're now halfway around. So the quarter phase, first quarter here and third quarter here. In first quarter, it's the right hand side of the moon that would appear illuminated. And third quarter, it's the left hand side of the moon that would appear illuminated. Gibbous phases are more than halfway around. And again, you would see more than half of the illuminated portion of the sun. So the portion pointing toward Earth, we see larger chunks of the moon illuminated, and up to the full phase where the entire surface, and that is always opposite to the sun in the sky. So the full moon will rise right as the sun sets and then set as the sun rises. So what phase we can see depends on the time of day. So the waxing phases will be visible in the evening sky. The waning phases will be in the morning sky. And the full moon will be the one that rises right as the sun sets. So the one when what phase you're seeing, if you see a quarter phase moon, and for whatever reason don't know what time it is, you can figure out by which side is illuminated. And if it's the right side, that would be first quarter, and the left side would be third quarter. So you'll note that for waning phases, it's always the left side illuminated. For waxing phases, it's always the right hand side that is illuminated. Now, we talked a little bit about the rotational period of the moon. Let's look at that again here. The rotation and revolution of the moon are exactly the same. What do we mean? Well, rotation is how long it takes to spin on its axis, and revolution is how long it takes to spin around the Earth one time. That means that one side of the moon always faces the Earth, which is what we call a synchronous rotation. And that's what we see here. It means that the moon is rotating. So if the moon were not rotating, we would always keep one side would be facing in the same direction. And here we would see one side of the moon, and here we would see the other side of the moon, because that side would be constantly facing in the same direction. However, when it rotates and revolves at the same rate, one feature on the moon pointing toward Earth is always pointing toward Earth. And what that means is there's half of the moon that we always see, and it's always the same half no matter when you look at the moon. And then the other half is never seen. So let's look a little bit at a animation here to look at the rotation of the moon. Let's look at our moon, and we start with the side we're used to seeing, and then we'll see the other side, what we call the far side of the moon. It's not really a dark side. Sometimes it's dark, sometimes it's light. It just depends on the specific timing of the month. But each side of the moon will get the same amount of sunlight over the course of a month. Now, this other side was not visible until 1959, when the Luna 3 spacecraft flew around the moon and was able to get our first images. And we see that it's quite different. When we look at our side of the moon, the near side facing Earth, we see lots of dark patches. When we look at the other side of the moon, we don't see that. The far side of the moon is very light colored and doesn't have a lot of the dark maria that we're used to seeing when we look at the near side. So there are some big differences between that, and we'll look at that a little bit more when we get to our section on the moon. Now, what else does the moon do? Well, the moon actually causes tides as well. And they are caused by the moon and the sun, and it is caused by a differential gravitational force. Essentially, what that means is that the moon is pulling more on the near side of the moon than it is on the near side of Earth than it is on the far side of Earth. So we're getting a stronger pull here than we are here. And that means that we will get a distortion. It's trying to tug the Earth, and it will try to deform the Earth. Well, rock doesn't deform very well. So but water does flow. This is why we get the tides. That the moon is trying to deform Earth altogether and stretch it out. The solid rock doesn't deform very well, and the moon doesn't have a very strong gravity. So it ends up with the water being that which can flow. And again, this is because of the gravitational force. Remember, that depended on the distance. So the near side is closer, and that means it has a stronger force pulling on it. And the far side with a greater distance will have less of a force pulling on it. Now we can look at this another way as well. Let's take a look here. And what we see is that we're going to watch this animation. It's going to show two different types of tides. So we see that the sun also produces tides, a tidal force, but they're about half the strength of the lunar tides. So they're not near as strong. So what we have is during new and full moon, we get spring tides. And that's what we see when we get to on the left and the right sides of this image. So at that point, we will see that the tides add together, the solar and lunar tides add together, giving us a much stronger tide, a much higher high tide and a much lower low tide than we would otherwise see. At first and third quarter moon, the forces work against each other. The moon is pulling tides in one direction, the sun in the other, and we get lower tides than we would otherwise get. The stronger tides at new and full moon are called the spring tides, and the weaker tides at first and third quarter moon would be called the neap tides. So let's go ahead and finish up with our summary. And what we found this time is we looked at the phases of the moon and that they depend on the positioning in the sky of the sun and the moon. Specific phases are visible at specific times of day. And tides, we looked at the tides caused by the differential pull of the moon and sun on Earth, and the water moves more or less depending on that excess force. So we will get high tides and low tides at different times depending on how those two are together. So that concludes this lecture on phases of the moon and tides. We'll be back again next time for another topic in astronomy. So until then, have a great day, everyone, and I will see you in class.